Good morning, good afternoon, or good evening. Wherever you are in the world, welcome and thank you for joining us. My name is Carl Anthony, and this is AutoVision News live at AutoSense Detroit 2023. We are set up here in the heart of the Motor City, downtown Detroit at the Huntington Place. With us is David Arthur, the CEO and co-founder of CHASM Advanced Materials. David has more than 35 years of experience in executive and leadership roles, including work at Rogers Corporation, AT Cross, TPI Composites, Helix Technology Corporation, and more. He holds a BS in Chemical Engineering from Tufts University and an MS in Chemical Engineering from the University of Connecticut, as well as an MBA from Northeastern University. He was recognized by Nano Business Alliance as one of the top 10 most influential people in the field of nanotechnology and is an inventor with over 30 patents. David, welcome to our program. Good to have you here.
Pleased to be here. Thank you.
So, David, a little while ago, we were in a press conference. So my brother and I, Alex, who's at the camera running the controls here for this broadcast, please take this as a compliment. We were blown away, literally blown away at what you were showing. And we've got some stuff here on the table. So let's start first, though. Provide a brief overview of CHASM Advanced Materials, get us up to speed on the company, and then we'll dive in more here.
Great. Well, thank you.
Yeah.
I co-founded CHASM in 2005 with my co-founder, Bob Prino.
Okay.
And my background is nanotechnology.
Sure.
Before it was fashionable to call it nanotechnology.
Yeah.
My partner, Bob Prino, his expertise is he's world recognized in coatings and roll-to-roll manufacturing.
Okay.
And so we formed a consulting business in 2005 and to help our clients develop and commercialize advanced materials.
Sure.
The sweet spot was nanotechnology and coating.
Yeah.
And so we had more than 100 clients over a 10-year span, very successful consulting practice. But we decided to make a bold move and we acquired our largest client.
Yeah.
And so they were a manufacturer of carbon nanotubes, a material that we were fascinated with.
Sure.
And we found that a lot of the customer applications we worked on included that raw material.
Sure.
And so we're now proud owners of a carbon nanotube manufacturing plant in Norman, Oklahoma. Yeah. And we have our headquarters in the Boston area. Okay. Where we have our headquarters in an applications development center.
Okay.
Yeah. So in 2015, we made a pivot, and now we develop and commercialize our own advanced materials products.
Okay.
Very different business model, a lot more capital investment required. So that's when we started taking in equity capital from investors.
Right. David, the items that are on the table here, what you're showcasing at AutoSense, and this is the cool part. Can you take us through each of these items one by one?
Sure. Well, a common ingredient in all of our product solutions is this remarkable material called carbon nanotubes.
Right.
And carbon nanotubes are hollow tubes of carbon. They are tiny, about the same size as DNA molecules.
Okay.
So nanometer scale, if you will.
Right.
And they're the strongest materials known. Mm-hmm. They conduct electricity and heat very efficiently.
Right.
And you have the chemistry of carbon. It's a very stable material, resists heat, resists chemicals, moisture, and so on.
Sure.
So it makes for a really interesting material to incorporate into advanced materials system.
Sure.
So that ingredient is in every one of our product solutions.
Okay.
And so in one of our product lines is transparent antennas. And you can see this is a Wi-Fi antenna.
Okay.
And we have done not only Wi-Fi antennas, but we have done GNSS antennas.
Right.
We have done 5G cellular antennas, NFC antennas, Bluetooth antennas, you name it.
Right.
We've taken antennas that normally are not transparent, and we've made them transparent, and they perform just as well.
Sure.
So this isn't the focus of this show, but it's pertinent to the automotive industry, and pertinent to our everyday lives.
Right.
So as 5G becomes more and more popular, more and more antennas are needed. As the Internet of Things becomes more and more established, more and more antennas are needed. People don't want to see all these antennas all over the place. Right. So that what they really want is the antenna to be invisible.
Yeah, right.
And that's what we enable with our technology.
That's cool. Yeah.
Another important application area for us is transparent heaters.
Yes.
When you may have experienced, like I have, in my car tells me when it's bad weather outside.
Yes.
Your safety sensors are not working.
Yes, right.
I get
Correct.
this alarming message, right?
Right.
And it's because the lens covers get snow or ice or frost, or in some cases just even rain on them, will prevent the ADAS sensors from working properly.
Sure.
So what we have done is we've developed a transparent heater foil that can be integrated with those lens covers,
right,
to keep those surfaces clear.
Yeah.
And then the ADAS sensor system has a fighting chance to do what is already a difficult job under perfect conditions, right? And so our transparent heater foil technology, we basically take, like the transparent antenna technology, we take a copper micro mesh that is supported by plastic film, and then we print carbon nanotube ink on top of it. And the carbon nanotube ink is very thin, but the carbon nanotubes are very efficient at transmitting electrons. And so this combination of carbon nanotubes with the copper micro mesh is way better than either material alone.
Right.
And so we call it a carbon nanotube hybrid solution, and that's what you see in front of you. And these type of films have more than 90% transparency.
Sure.
Is which you can see. I mean, I can see you very clearly. You can see me very clearly.
Clear as day. Yeah.
And it's very thin. It's only about 100 microns thick, or 1/10 of a millimeter.
Right.
It's flexible.
Yes.
It's formable to a 3-dimensional shape. You can shape it.
Of course.
So it's a very robust material system, and it's very affordable to produce this.
Right.
Because nanotubes are known to be more expensive materials, but we only put on about 1 to 2 milligrams of nanotubes per square meter.
Right.
There's only a tiny amount of nanotubes here, so the cost is really not big a deal at all. So this material solution is what's called a transparent heater foil.
Right.
The incumbent is microwire. Now, all of us are familiar with that when you look through your rear window defogger.
Yes.
So it works okay, but it melts ice at the wires first, and it does that quickly.
Yes.
And so you can kind of see through it. Yeah. The person can see well enough at that point, but a sensor wouldn't like that. The sensor would want that entire lens cover surface to be clear.
Yes.
So it takes a lot longer for the spaces in between the microwires to get clear.
Right.
Whereas with our transparent heater foil, there's no microwires.
Right.
It heats evenly across the entire surface.
Right.
So the ice melts at the same time.
Yes.
And so therefore it melts a lot quicker.
Right.
For a human to look at it, and also for a sensor to look through.
Yes.
Now, very importantly, the microwire, I said, does the job, but people and sensors don't like looking through opaque microwires once that lens surface is cleared.
Right.
Our transparent heater foil is different from competitive transparent heater foils.
Yes.
We don't have microwires, and the competitive ones, there's some out there that don't have microwires either.
Sure.
But where they struggle is they struggle to de-ice within the industry desired 5 minutes.
Yep.
If you limit the voltage to 12 volts.
Yes. Right.
And so they require higher than 12 volts. And electric vehicles are going to have the infrastructure within the vehicle to deliver higher than 12 volts.
Right.
But none of the OEMs want to run their components at those higher voltages. They would rather just stick with 12 volts.
Yes.
And use the high voltage for the running the vehicle.
Right.
And so we can do the job with 12 volts, and that's a big point of distinction.
Yes.
The other thing that's very distinguishing for us is we're transparent not only to visible light, but we're transparent to Lidar, which is at 905 and 1550 nanometers, We're transparent to radar, which is in the millimeter range, 77 gigahertz.
Yep.
And so we're transparent at all of those wavelengths.
Yes.
So one transparent heater foil is compatible with camera, Lidar, radar. And there is no other technology out there for heater foil that's compatible across all three of those sensor platforms.
Right. Essentially sensor fusion. You're compatible with sensor fusion, which is the biggest topic right now.
Absolutely.
Yeah.
I've been hearing that term nonstop since I've been here.
Yeah. But that's what you're describing, is that compatibility.
Exactly.
Yeah.
And here's an example. I cannot name the company, but it's one of the leading tier one suppliers. And behind this will get dome shaped. It will get three-dimensionally shaped. But behind this is going to be radar and camera, both behind the same lens cover. And so that's, shows that we have an enabling technology for cluster solutions, which are very much aligned with the fusion strategy.
Yep. What is this one here, David? What's this one?
This is illustrating, this is a thin heater foil.
Okay.
How do you integrate this into a lens cover assembly?
Sure.
Right.
Right.
And so what we do is this can be three-dimensionally shaped.
Right.
And it can be inserted into an injection molding tool. And then you can injection mold plastic around the heater foil. And so the heater foil is basically encased with plastic.
Right.
And
so cool.
When you pop this out of a mold tool, you have a lens cover assembly, not just a heater foil.
Right.
It happens to be heated by a heater foil.
Right.
And so there's various ways of integrating the transparent heater foil into a lens cover assembly.
Right.
One is, the most complex one is the film insert molding, or FIM method, which is what's illustrated here.
Okay.
But you can also do over molding.
Sure.
Where you just mold plastic on top of one side.
Right.
Or you can do optically clear adhesive lamination, where you just stick the heater foil to a surface, could be glass or plastic.
Right.
All three of those methods are compatible with our transparent heater foil solution.
Right. Right. When it comes to, we were talking after the press conference, David, coming into this space, coming into automotive, where does CHASM fit in the automotive and ADAS supply chain? And then what is your current status then regarding business development and commercialization? Kind of a long-winded question there, but something I just took from the press conference as we were walking out the door talking together.
Yeah, it's a really important question that we've thought long and hard. How do we position ourselves? We're a new player in the automotive industry. We're a seasoned veteran in the nanotechnology industry.
That's right.
But we're a new player in the automotive industry. So strategic partnering is very important to us. And that's one of the benefits of this show, is be able to meet people. And then benefits of me talking to you, which I'm grateful for. That
You're welcome.
You can help us spread the word.
Right.
But in this, our supply chain design is we make a transparent conductive film. So it's the film here minus the printed bus bars, minus any trimming, minus any connectors that might go on this.
Right.
And so the film gets supplied to a tier 2 supplier, which is basically a flexible printed circuit fabricator.
Yeah, okay.
And they can convert our film to a transparent heater foil.
Right.
Right. And so this is ready now to go to the next step, which is to be integrated with a lens cover assembly.
Right.
And that typically would be done by a tier 2 supplier.
Okay.
And then the tier 2 supplier would supply the assembly to the OEM.
Right.
So we're positioned at the very front end of that.
Sure.
We make the transparent, make all of our own carbon nanotubes.
Right.
We make inks out of those nanotubes.
Right.
We have a strategic supplier make the copper micro mesh.
Sure. Sure.
And we print.
Right.
So we supply the film, and then a tier 1, tier 2 OEM. That's the supply chain design. Importantly, though, at prototype stage, no one cares more than we do to validate fitness for use of our transparent heater foil, right?
Sure.
So we have established in our Boston area facility a prototype fabrication shop.
Yeah.
So we can make fully functional transparent heater foils We can even collaborate with a third party to integrate them into a lens cover assembly.
Right.
But deliver for validation testing.
Yes.
Something that the tier one or the OEM can measure for themselves. Does this solution work?
Yeah. Right.
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 And then the next step for us is to work alongside them to design it for manufacturability.
Yes.
And we ultimately would hand off to a tier two supplier.
Yeah.
And we will involve the tier one in the selection of the tier two supplier,
Right.
because at the end of the day, they will be buying from the tier two.
Yes.
Right. And the OEM will be buying from the tier one.
Right.
Now, some OEMs are vertically integrated, and some tier twos are vertically integrated.
Sure.
So there's kind of a blur, but
Right.
I think you get the picture of the supply chain design.
Yeah. It's still incredible, David. The thing that blows my mind is how do you look at, say, the automotive industry, and then you say that's where we want to go. We have this expertise elsewhere in the nanotechnology. How do you wake up one day? How do you come up with this idea, looking at automotive and saying that's where we want to go, that's where we want to innovate? How did you think this idea up? This is amazing.
Well, first of all, it's not just me. There's a
Yeah.
there's a team of people at
Sure,
CHASM.
sure.
But you know what? We tried a bunch of things.
Yeah.
One of the charm and challenges of carbon nanotubes is you could convince yourself they could solve any problem.
Yeah, right.
They're such remarkable materials.
Sure.
And so we were grabbing for too many shiny objects.
Gotcha.
Right?
Yeah.
So we had to go through a really rigorous process. What are the best target applications for our carbon nanotube product solutions?
Yep.
And there's one material in transparent conductive films that has dominated the transparent conductive film industry for decades, like 4 decades.
Right.
It's a material called indium tin oxide, or ITO.
Okay.
It's a clear conductive film on plastic or glass.
Yeah.
And we said, we're tired of getting beaten by ITO because they're so established, and they can always just reduce price.
Yeah.
So we want to target applications where ITO is irrelevant.
Sure.
Right. And so ITO cannot make a transparent antenna because it's not electrically conductive enough to give high-end performance.
Right.
ITO is brittle, so it will crack if you try to form it.
Right.
And ITO also is not low enough in resistance to be able to de-ice at 12 volts in 5 minutes or less.
Yeah.
So we've chose to target applications where ITO was irrelevant, and we chose applications that had potentially huge addressable markets with high growth.
Yep.
And, I have to admit, it's been, in terms of our business development, it's been a long haul in the automotive industry to being a new entrant with a new technology. It takes years to get through the qualification.
Right.
The good news I can say is we're partway through that. We'll into that, but we still have some more time to go before all the boxes are checked off enough that we'll get designed into a vehicle.
Right.
And so we have also, in parallel with that, been pursuing industrial applications for our transparent heater foils.
Yep.
And we have units that are in the field for remote weather information systems.
Sure.
It's kind of the same principle. They will these monitoring systems will sit on top of light poles that are looking down at roadways.
Yep.
And they use camera and Lidar to tell what is the condition of the roadway.
Yeah.
And when do you want to have that information? Why is that? When is it most important?
Right.
When it's bad weather.
Yes.
And when it's bad weather, they have the same problem if the lenses are not kept clear.
Right.
And so they're using our heater foils across the country. There's quite a few of these units where they're working properly because the camera and the Lidar sensors are looking through a clear lens cover.
This is fantastic. David, just a couple weeks ago here in Michigan, we had a late season rain snow mix. My adaptive cruise control sensor out, my blind spot monitoring struggling, my reverse camera completely covered. I got the same notifications you're talking about. This kind of stuff is a game changer. David, thank you so much for your time. being with us, sharing your expertise. I want to encourage all of our viewers to please connect with David on LinkedIn, and please visit the CHASM Advanced Materials website. We also have CHASM Advanced Materials tagged here to this LinkedIn post. Please connect with and follow the company. David, we wish you all the best of luck going forward, and let's definitely do this again sometime soon.
Thank you so much.
You bet, David. More to come from AutoSense Detroit here on the AutoVision News LinkedIn page. From the Huntington Place in downtown Detroit, I'm Carl Anthony, AutoVision News.